Okay, welcome again to Mercer Locomotive Works. Here we are, good old Trenton, New Jersey. Anyway, today I'm making a part, and what it is going to be is ring or blowback ring for the differential. So in other words, when it pops off at say 120 pounds, there's a special adjusting ring in there that allows it to only drop 5 pounds or 3 pounds or whatever, how many pounds off the, like drop down 3 pounds and then shut down. And there's a ring that does that. It's adjustable. And in order to do that, I'm going to make, I can make the thing one of them, the 1/8 of an inch thick. So what I'm planning on doing is I happen to have this 3/4 inch piece of brass, which actually was a propeller shaft at one time, and I turned it down to fit in here, and I had to use the regular nut that hold the propeller on. I just tightened it up there, and I got it in here. This is the rotary table, but it also has an indexing plates that come with it, and I'll explain that in a minute. And then of course I got the center here, and what it's going to be is a 3/4 inch diameter piece that later on is going to have a tapped hole in the middle. It's going to be 1/2 inch 32 thread, and it's going to have another seat on it and so on. But I wanted to make a whole bunch of them, so I have, in case I want to make more safety valves, I got a whole stick-up load of them. And it requires to have 45 little notches, 30 thousandths deep, all the way around. And if you take 45 divided into 360 degrees, comes out to every 8 degrees you have a notch. And I laid it out, and I'll bring this up close so you can see it. Laid it out here on the on AutoCAD, and good old AutoCAD. Let's see, I have it right side up, yeah. Okay, you see this red right here, that right there, right here, the red part, that is the representation of the end mill. And of course the center lines here, you know. And then I'm going to touch off the top very carefully, and I'll show you how I do that. And then I'm going to touch off the side over here, and 0, 0. And then of course, according to my indications here, how much I come down and how much over. And then I'm going to run the whole length of that. Put my print over here. The whole length of that all the way down. But before I do that, just to make sure I'm not going to waste the whole piece, I'm going to do about 1 inch of it all the way around to see how it comes out. And then once I'm happy with that, then I'm going to run the whole length of it all the way down, and then I'll have basically a stick of them. I put it in a lathe and turn them down. Drill it, bore it, tap it, trace the threads, whatever, and then cut them off with a very small cutoff tool, thin cutoff tool, so I don't waste a lot of material. And I'll have the pieces one after another. Then of course I'll have to face them off and do whatever I got to do on them later. But indicating this, what I did was I roughed it out with I used just a regular square, and then roughed it out, got it pretty close to being right there. And then clamped it, roughed the clamps out, and then run the indicator on here on the top and on the side, because on the top, this center is adjustable this way or that way or down or lower if you want to make a tapered part. That's what that's for. So you have to indicate this, and you get it so everything is, and in fact, it doesn't matter what this is, it matters where the 45, right where you're cutting the 45. That's where it makes the difference. So now I'm going to pick up this with the end mill, top and the side, and I'm going to cut the grooves. Now we'll talk a little bit about the indexing plate. Now it's every 8 degrees, so the way it works out is you pick the number of the plate number, and this one is, I'm using the 39 plate. Okay, now I don't know that much about them, but I got it marked, and what it worked out was I checked it 2 times around. So let's see, unlock it, 1, 2, and then back in the same hole. That's 8 degrees, shows there. Another one, let's see, why is it so tight? Okay, 1, 2, back in the same hole, lock it and cut. And that's the way it works out. I checked it out all the way around. I'm not that familiar with using an indexing head. I never really made gears back in Folk Tech school, made them, but bevel gears, so on like that, and there's 18 guys making the same bevel gear. Anyway, I never really had much use to make gears. Some of you model engineer guys out there make gears and stuff, and the truth of the matter is, I generally, when I'm designing something, I generally work around a gear that you can buy. In case something goes wrong with it, you can always get another one. But I generally try to make whatever I'm designing around off-the-shelf products. So I'm going to go ahead now and get this set up. I'm going to pick up the top and the side, and I'll show you how I do that. And then we're going to start making the cuts. All right, I got the machine fired up, and now what I got here is just an ordinary piece of the pad over here that I scratch things on, make drawings and whatnot. And it's a couple thousandths thick. Generally, paper runs about 3 thousandths thick. So what I do is I put it underneath here very carefully. And let me tell you, and a word of warning, when you hold this stuff, don't hold it real tight like that. Hold it so it's like it slip out of your finger. Because that thing will grab it and actually pull you in, and you could get hurt. So just hold it very lightly with your fingers, and it'll slide out if you should grab it. But that's how you're going to pick it up. Now I could use it. Use an edge finder and all. Piece of paper. Poor man's edge finder. Works fine with me. Slide it up under there, and it'll come up close. And then you carefully slide it up underneath there. And then you just bring the table up to hit it. And it starts to cut it. There. I'm within 3 thousandths. Within 3 thousandths of the top. Now I'm going to just come up. I'm going to come up 2 and see what happens. No, that's too much, see? Try it again. Try it again. Alright, just touch it. Okay, and I'll come up. I'll come up 2. See what happens. Hang it 2. Now, I've got the lock snug, not tight, but snug. That's it. Okay, I didn't hit. I'll come up 1 more. Lock. That's too much. Come back and stay at the 2. I'm going to back it off. I'm going to like that. I'm going to set this at 0. I'm going to set it at 2 pass, 1 pass 0. So come back. Always go back and then come up 2. Always remember that. Always go in the direction. Come up 2. Okay, now I lock that. Come over. I'm just kissing it. Okay, so now I know where that's at. I'm going to come up probably 4 turns. Okay, remember we did 4 turns. I'll come up 1 more turn, 5 turns. Okay, now I'm going to use the side here. And I'm working on that side because that's the way my cut is going to go. Going to go that way. So I got it all figured out. I can be able to cut the whole length of this rod, just about the whole thing. By the way, I have a 32-inch table on this. Bridgeport's, when they first made them, they made them with 32, 36, and then later on 42, and now they make 48. Which, I mean, you know, I'd like to have a 42-inch table. I really don't need it because I got the big table over here on the green machine. So, anyway, you do the same thing with the paper. You come in. So it starts to hit the paper. Oh, see, it just pulled it out. Okay. That's just kissing it. That's it. Perfect. Okay, now you set your Y. X don't matter right now. You don't care about it. I set it anyway. Make sure. Okay, now that's that. So I know the 0 on the top and that. Alright, let's run it back down. Come back over. Come back up to 0. There's 0. Okay. So when I go 0 here, when I'm 0 there, that's only 8/10. When I'm 0 there, then I'm on the quarter of it. 3/8 over, it's 3/4 diameter. So it's 3/8 over from center, 3/8 up from center. That's where the edge of that end mill is. Hopefully. Now the depth of the cut is only 30 34 thousandths, I think. So it's only 34 thousandths, so you don't have much to play with. When I set up this, I wanted to be within 1/1000th of straight. That's probably good enough. It's nothing that precision. It's just a notch that when you finally adjust the safety valve, a little set screw goes in and holds it from turning anymore. That's all it does. And then if you need to readjust it while it's under steam, you back it out closer, makes it pop quicker, shut down sooner. It's a right-hand thread, so that direction makes it closer to the poppet. Clockwise direction, if you want to look down on the top, clockwise direction makes it further away, so it'll drop it down, say 5 pounds versus 3 pounds. Anyway, that comes later. It'll be adjusted. Okay, now according to the drawing here, and I gotta commend CAD on this CAD. That's Chad Aloysius Delaney. That's Charles Nelson's friend. Anyway, I'm going to use these dimensions to come over and to get my notch. Now you can just see the notch right. I think it's right here. You can just see that little notch. And I'm going to go all the way down. Now the way I have it set up is at the top, the peak of each notch, I have a little flat. I don't want it to be perfectly sharp, because I want to be able to hold a collet, and I want it to be somewhat concentric. So we'll see how it works out. It's not that perfect. It doesn't need to be that perfect, but I'm going to try to make it perfect if we can, because that makes the fun of it. But we don't have to worry about it. I got these rare earth magnets here. They're strong. Okay, so now let's see. What are we going to do? We're going to come up 127, and we're going to go over 120. Well, 128 and 128. So let's go away. 128, 128 is right there. Lock it. And we're on 0 here. Now we got to get back to 0. Go past it and come up to the mark. There. Okay, that's 0. That's the first cut. I'm only going to go in about 1 inch. Okay, that's that. And then we're going to go over from 0. When I get to 0, 128. 1. There's 1. Eight. Okay. Now lock that, because I don't want that to move. See, now it moves a little bit, so you got to adjust a little bit. Just bang it. It's not that important, you know. Okay, 127 and almost 8. All right, now that's the initial thing, because that's my 0, 0. So I'm going to jump up to 0, 1, which is 0, 1 is another set of coordinates. I got 200 of them on here. So that's, I don't know, I don't have to set the X. I just have a habit of doing that when I start off. Okay, so now that's it. Let's see what happens. Just go in a couple of turns. Okay, now you got to go 2 times around. 1, 2 is 8 degrees. So 1, 2. There's 8. Lock it. Take another cut. One, 2. It don't have to be that tight. Just snug is good enough. Snug is good enough. Alright, another cut. Now it's a little tough to see. And another cut. 1, 2. Gotta go around 45 times. It says it's easier to do it right now to just double check my work. I mean, I'm not perfect. I'm no genius, even though I might think I am. Anyway, I make sure I always double check everything rather than waste all the material, I'll make sure it's right. If I can adjust it, maybe a little deeper, a little bit further over, a couple of thousandths, make it a little bit deeper and see what happens. It looks like it's going to work out. Okay, I get the cut running now. I went around one time, you can see it here. Knurl, looks like a knurl. Came out pretty good, right on the money. So I'm going to run the whole length of this, all the way down, run it all the way back. I really don't want to change the setting. I could go away. I might try one. Go back to 0 again very carefully and go down. One cut, one cut, one cut. 45 times all the way around. When I get down to the end here, I'm going to set the stop like this so it stops running. So I don't have to worry about it. I'm working around the shop here and let's let it go. That's my version of CNC. Alright, getting near the end of the cut. As soon as it gets down to the end, I'll stop the feed and set the little stop there. It hits the little, just hits a button there and shuts it off. No rocket science, you're there. And then I don't have to worry about it, you know. I don't know, I haven't timed. I'm going to time see how long it takes for one cut. Time 45, maybe say 45 times. And that's how long it's going to take me to do it. No big deal. It's getting there now. Another 2 inches or so to go. Index it, and then start another cut. Come back in and start another cut. Alright. Go into 0. Okay, make 2 turns, back to the thing, get over here, start, and go down. Right in the same groove, should be. Nothing's been moved. There you go. Cutting all the way down. Looking good. Looking good. I really enjoy this. I don't know why anybody would want to run automatic machinery, CNC stuff. I mean, you could have that thing so it automatically indexes over here while you're playing Monopoly or something. You know, this is the enjoyment of doing the part yourself. Alright, there's a certain amount of conveniences, like I have automatic feed, I can sit there and turn it by hand, and I don't have, you know, without a readout, things like that, but to actually make the part and have somewhat hands-on is where it's at for me. Everybody says, why do you keep harping on CNC? Well, because, I don't know, I think in our hobby, in the model engineering hobby, you should really make the parts yourself. So, it's the enjoyment for me. Well, keep cutting. I don't know how long it's going to take me. I'm going to time. I just timed the last cut. At the beginning, I started it, stopwatch, went all the way down, I went out, come all the way back, reset it for the next one and went down. As I started it, I shut the clock off. It's 5.5 minutes per cut. So times 45, 250 minutes divided by 60 minutes, tells you how many hours. About 4 hours to do it. But, you know, I don't have to be here 4 hours. You know, I can work a couple of hours, make a few cuts, stop. Always make sure you finish, completely done. Stop, get ready to do the next one. Make a note if you have to. Come back in 2 days, do it again. So we're going to continue to keep cutting them. When I'm all done, I'm going to have a nice bar of blow-down rings. Well, one thing I wanted to mention is that there's this little gizmo here that comes with the indexing head. And this works for any indexing head. This one just has to be hooked up on a rotary table. I've got all the different plates here with the different amounts of holes, like 20 holes, 15 holes. They're all odd numbers. And what you do with this little thing is, let's say you have the first pin there and you're making a cut. Now, while it comes around, you run this around to there, and the next time it comes around, it goes to that hole. And then, you know, you just keep spinning it around. Cutting away. I got another 3 hours to go, but I doing other things. I'm starting to work on the tender now. Locomotive is done. Working on the tender. I got a few things I want to do there. Waiting for a safety valve to come in. When the safety valve comes in, I'll hook that up. In the meantime, I'm still going to work on my own. Just something that I always wanted to do. And I wanted to mention, you know, Super Scale, they make a beautiful safety valve. I've been a big believer in them for years and years. In fact, I was probably one of the very first, if not the first, to bring them back to the East Coast here in 1980. On the first trip out to the Promised Land, I met Barry. I knew him prior to that, but met him and bought some safety valves and brought them back, and got rid of my big old Conkle valves and put the Super Scales on, and they work great. But I always wanted to make one. I never did because I was able to get them from Barry. So now I figured, let me try and make one. I got a little time on my hands, something I always wanted to do, and I'm going to attempt it. Hopefully it'll come out. Maybe it won't, maybe it will, but I'll follow through with it and let you know what happens. We'll find out on through the video. Well, okay, that's it for now from Milling Machine Central. And be a while yet. I'll probably cut them a couple of more hours today and some tomorrow, and probably some on Saturday. And it'll get done little by little. So when it's all completed down the road, I'll show you what it looks like on the end. But I'm having a little fun doing it. So that's it for now. See you on the next video. Thanks for watching.